A reflexive property of relation is a relation R on a set X is reflexive if whenever X is an element of X, then X, X is an element of R. A relation R on a set X is not reflexive if there exists some X is an element of X such that X, X is not an element of R. We should follow the rule of reflexive, wherein X should be less than or equal to Y. So one example here is, consider again the set of my family members as F. Sabi dito, if F is the variable that is used, and yung laman ng F natin ay Cedrick, Mickey, Hina, Mila at Gavin. Kung susundin natin yung rule na X should be less than or equal to Y, makukuha natin yung value ng R as Cedrick and Cedrick, Cedrick and Mickey, Mickey and Mickey, Mickey and Cedrick, Ina and Ina, Mila and Mila, and Gavin and Gavin. Another example here is, consider the set of numbers 1 to 4 as n. Ayon sa instruction, ang variable na ginamit natin for the numbers is n, which is also the set. Ang set n natin ay nagko-consist of numbers including the numbers 1, 2, 3, and 4. Ngayon, kung susundin natin yung rule na X should be less than or equal to Y, ang R natin ay maglalaman ng mga value na 1 and 1, 1 and 2, 1 and 3, 1 and 4, 2 and 2, 2 and 3, 2 and 4, 3 and 3, 3 and 4, at 4 and 4. The last example for reflexive property of relation is, consider the set of letters as A to E as L, given that the letters have the values of their own numerical equivalents. Ayon sa instruction, ang variable na L, which is the set, is supposedly maglalaman ng letters na A to E, or to be more specific ay letters A, B, C, D, and E. Ang value daw ng bawat letters sa laman ng set ay nakadepende daw sa kung pang ilan ito sa bilang. Kunyari, ang letrang A ay pang-una. Siya ang maghahawak ng value ng 1. Kung susundin ulit natin yung rule na X should be less than or equal to Y, therefore, ang magiging value ng R natin ay A and A, A and B, A and C, A and D, A and E, B and B, B and C, B and D, B and E, C and C, C and D, C and E, D and D, D and E, at E and E. An irreflexive property of relation is a relation R on a set X is irreflexive if for every element X is an element of X. It follows that X, X is not an element of R. A relation R on a set is not reflexive if there exists some X is an element X, such that X, X is an element of R. In irreflexive property, we should follow the rule of irreflexive wherein X should be less than to Y. So here we have an example na katulad din dun sa may example kanina sa reflexive. Consider the set of my family members would be is a parent of, because a person can't be a parent of himself or herself as F. So sabi dito, a person can't be a parent of himself indicates that x is always less than y, and x cannot be equal to the value of y. So our f consists of Itzik, Mickey, Ina, Mila, Gabi. So our r should be equal to Mili and Itzik, Mila and Mickey, Mila and Ina, Gabi and Itzik, Gabi and Mickey, Gabi and Ina. All indicates that Mila has the lowest value of them all. Another example is also based on the previous example from the reflexive property of relations. Consider the set of the numbers 1 to 4 as n. N is equals to 1, 2, 3, and 4. This time, tinanggal natin yung equal, or gamit tayo ng rule which is x is less than y. So our r is also 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. Tulad din siya nung sa reflexive, ngunit tinanggal natin yung 1, 1, 2, 2, 3, 3, and 4, 4. So our last example is also based from the last example of reflexive property of relations, wherein our set L consists of letters that has the value of their own numerical equivalence. Example is A is the first value, then it takes the number 1, and so on. So our L consists of A, B, C, D, and E. If we use the rule x is less than 2y, it is also the same as the reflexive, but it removes the AA, BB, CC, DD, and EE. So our R is equals to A, B, A and C, A and D, A and E, B and C, B and D, B and E, C and D, C and E, and D and E.
So one of the properties of relation is symmetric. In symmetric, it tells that a relation R on a set X is called symmetric if and only if for all X and Y is an element of X, and whenever X and Y is an element of relation, then Y and X is an element of relation. So as you can see, this part, X and Y is an element of R. It says that these both element X and Y, if they exist, then Y and X also exist in the relation. So in the example, we let X as the relation, as the set of 1, 2, 3, and 4, and we define the relation R using the two rules X is less than Y and X is greater than Y rule. So if we solve the relation using the symmetric property, we will obtain 1 and 2, 1 and 3, 1 and 4, 2 and 1, 2 and 3, 2 and 4, 3 and 1, 3 and 2, 3 and 4, 4 and 1, 4 and 2, and 4 and 3. So as we can see, the first rule, X is less than Y, this rule satisfies this one. 1 and 2, which represents 1 as X and 2 as Y. So X is less than Y. Same with 1 and 3, 1 and 4, 2 and 3, 2 and 4, 4 and 1, wrong. x is less than y just satisfies the rule, the pair of x and y with 1 and 2, 1 and 3, 1 and 4, 2 and 4, and 3 and 4. So if we could only observe, this pair of elements says that x is less than y, which yes we are. The first element represents for x and the second element represents for y. So the next rule, x is greater than y, such as 2 and 1, which the element 2 represents x and the 1 represents y. So in this example, in this pair of element, x is greater than y. 2 is greater than 1, 3 is greater than 1, 3 is greater than 2, 4 is greater than 2, 4 is greater than 1, and 4 is greater than 3. So that is the symmetric property. Next definition, since 1 and 2, 2 and 1, 1 and 3, 3 and 1, 1 and 4, 4 and 1, 2 and 3, 3 and 2, 2 and 4, 4 and 2, 3 and 4, 4 and 3 are all in R. The relation R on set X is symmetric because for all element X and Y, just like what we said on the first definition, X and Y, the first and the second element. So if we just first define Y and X. For example, element 1 and 2 and 2 and 1. These both satisfy the two rules, which are x is less than y and x is greater than y. Ay, mali. X is less than y and x is greater than y. So, in this one, it says here that whenever x and y is an element of R, which is this one, 1 and 2, x and y less than y, the rule, and 2 and 1, which is the same with 1 and 2, just that y was the first one to be listed, then x, but it also satisfies the rule x is greater than y. So they both exist on the relation R, which is 1 and 2 and 2 and 1. Then this relation is undeniably uses a symmetric property of relation. So we just have to remember that the symmetric property uses the rules of x is less than y and x greater than y. And as long as the element that represents for x and y also exists with I mean the element of x and y and y and x both exist in the relation, such as this one and this one. Yes, x is less than y and x is greater than y. This one, then they are symmetric. For the next example, in the set x, we have 3, 6, 9. So we're going to define the relation within that function through the use of symmetric property. So we must satisfy the x is less than y and y is X is greater than Y. So, for this rule, we could have 3 and X and Y, X is less than Y, 6 and 9. So, next is this one. X is greater than Y, such as 6 and 3, then 9 and 6. So, meron pa ba? We can also have 3 and 9 pala. So, konyo naman. 3 and 9. 4x less than y. X and y. And 4x greater than y. Also 9 and 3. So, there. We have listed all the possible pair of elements for the relation. So, if we could only observe, we have 3 and 6, x and y, 6 and 3, y and x, 6 and 9, like x and y, 9 and 6, y and x, 3 and 9, x and y, 9 and 3, y and x. So, according to the description, x and y is an element of relation. If also, then y and x is an element of relation. So, x and y, y and x. So, therefore, we have used symmetric property of relation. Next one is this one. Baka mahaba to. Try natin.
Ngayon pa lang namin nakilala yung
X is less than x greater than y and x is less than y. So we could have n2 1 and 3 1 and 4 and 1 and 5. Also 2 and 3 mali, ano ba yan? 2 and 4 and 2 and 5 and 3 and 4 3 and 5 for the rule of x is less than y. Then for x is greater than y, could have 2 and 1 3 and 1 3 and 2 4 and 1 tapos meron ding 4 and 2 meron ding 4 and 3 ano pa ba? Meron ding tama ba? Tama. 5 and 1 5 and 2 5 and 3 5 and 4. So, ito naman yung x is greater than y. Yan. Mas malalaki yung first element nila. So, once again, it's a relation because x and y is an element of R. It's like this one. It's y and then So therefore, y and x also, like 1 and 5, pinagbaligtad lang, di ba? So, andun din siya within the relation. So, therefore, symmetric yun.
What is an antisymmetric relation? Let's look at some examples. Please read and understand example number 1. Example number 2 is just a reminder about greater than and less than symbols on any set of numbers. R is a relation in set A. If A, B belongs to R, and B, A implies A is equal to B, then R is said to be antisymmetric. Set A contains 1, 2, and 3. R contains 1, 1, 2, 2, 2, 3, and 1, 3. R must satisfy the condition. If A, B belongs to R, and B, A belongs to R, implies A equals to B. So the ordered pair 1, 1 belongs to R. If we interchange the x and y coordinates, we get B, A, that is, 1, 1 belongs to R, which implies 1 is equal to 1, proving R is an antisymmetric.
An asymmetric relation is a relation R on a set X is called asymmetric if and only if for all x and y in the element of set X, whenever the ordered pairs x and y is an element of the relation and x is not equal to y, then the ordered pairs y and x is not an element of the relation. Let us see this example. So let X be set 1, 2, 3, and 4. We arrive at the asymmetric relation. We see that it is consisted of 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. We arrive at this by following the rules earlier. It is said that when x should not be equal to y. So the values that are equal to one another, x and y, like 1, 1, 2, 2, 3, 3, and 4, 4 are not included in the relation. The other rule says that y and x is not an element of the relation. So by flipping this ordered pair 1, 2, we will get 2, 1. We will see here that the flipped values of these ordered pairs are 2, 1, 3, 1, 4, 1, 3, 2, 4, 2, and 4, 3. These are also not included. That's all.
Transitive relation. So in transitive relation, it states that in any relation R, which is defined from set A, if A, B is an element of R and B, C is an element of R also, then we can say that A, C is an element of R. So here's an example. We have A, B, and C. So that A, B, and C lives in one village. If A is a neighbor of B and B is also a neighbor of C, then we can say that A and C are also neighbors. So in a diagram, we can say the relationship of A and B and the relationship of B and C is also the relationship of A and C. So what you should do is to look for the first ordered pair. So here's 1, 1, and look at the end element of that ordered pair, which is 1. So now look at the other ordered pair of the relation, which contains 1 as its first element. So since here we have 1 on the first ordered pair, we should compare, or we have now the value of A, comma B, and B, comma C. So what we are looking for is A, comma C. Is there any ordered pair in this relation which contains A, comma C? Yes, there is, which is 1, 2, and here it is. So next, move on to the next ordered pair, which is 2, 2. Pick up number 2 and find where it is located as the first element of an ordered pair, which is in 2, 3. So we have another set of AB and BC. Do we have an ordered pair which contains 2, 3? Yes, we do. There it is. So the transitive relation is satisfied. Next, we move on. 1, 2. So here's 2, 3. And that is another pair of AB and BC. So there should be 1, 3, and there it is. So we could say, therefore, R is transitive. Next, in sample number 2, we have this relation which is defined from set A that contains 1, 2, 3, and 4. So in this condition, we're going to notice that in the first ordered pair, given ordered pair, there are no other ordered pair which has the first element of the last element of the first ordered pair, which is number 2. So we can consider it as transitive. Also in this next pair, number 4 is not present as the first element of any ordered pair in this relation. So we can consider it as granted. Therefore, R is transitive. Now in this case, sample number 3, which is also like the example number 1, but there's an excess here which has 3, 3. So since the first sample is transitive, we should look for this ordered pair which is 3, 3. So are there any other ordered pair in this relation that starts with number 3? No, there isn't. So we should say that R is not transitive.
If and only if for all x, y, z is an element of x. Whenever x, y and y, z are elements of R. then x, z is not an element of R. Let x be equal to 1, 2, 3, 4. We define the relation R using 2x minus y greater than 0 and x not equal to y rule. Relation R has elements 2, 1, 2, 3, 3, 1, 3, 2, 3, 4, 4, 1, 4, 2, and 4, 3. Since 2, 1, 2, 3, 3, 1, 3, 2, 3, 4, 4, 1, 4, 2, and 4, 3 are all in R, and x is not equal to y, the relation on set x is intransitive. Because for all element x, y is an element of x whenever x, y is an element of R. Y, z is an element of R and x is not equal to y, then x, z is not an element of R.
Partial order relation. So first, i-define natin kung ano yung partial order relation. So, definition. So, ang partial order relation is a relation R set X is called a partial order if the relation is 1. Reflexive, 2. Antisymmetric, and 3. Transitive. So, basically, kapag pumasok siya dun sa tatlong condition na yun, matatawag na natin siya na partial order relation. So, punta tayo ng isang example. So, ito yung ating set. Let x be equal to 1, 2, 3, and 4. So, para makuha yung ating relation, susundan natin yung x is less than or equal to y rule. So, ang magiging relation natin is 1, 1 kasi they are equal. Then, dapat mas malaki si y. 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4, and 4, 4. So, yun yung ating magiging relation. So, una natin iti-test is yung kung reflexive pa yung ating set or yung ating relation. So, gagamitin natin yung x, x is in the element of the relation. So, yung x, x meaning equal yung dalawang ordered pair. Same value or same number. So, dito 1, 1, 2, 2, 3, 3, and 4, 4. Then kung mapapansin natin, lahat ng yan eh nasa ating relation na nakuha kanina. Yung 1, 1, yung 2, 2, yung 3, 3, and yung 4, 4. So since lahat ng to, itong apat na ordered pair nito nasa relation natin, sabi natin na ito ay reflexive. So ito is reflexive to. So, next naman natin na iti-test is kung antisymmetric ba yung ating set or yung ating relation. So, recall natin yung x, y is the element of x. Whenever x, y is the element of r, if x equal to y, then y, x is the element of r. So, yung x, y, element of r, ito yun, tungo sa taas. So, lahat ng to part ng relation. Yung relation, so equal sila. Then yung y, x, the element of r, ito yun. Binaliktad lang siya yung ilang ordered pairs na nandito. Yung 1, 2 naging 2, 1, 1, 3 naging 3, 1, 1, 4 naging 4, 1, and so on and so forth. So, dahil ito part ng relation, then ito is hindi part ng relation, matatawag natin ito na antisymmetric, itong ating set or itong ating relation. So, next na ating iti-test is kung transitive ba yung ating set or yung ating relation. So, i-recall natin, ang gagamitin natin is yung x, y, z is the element of the x or set x. Whenever x, y and y comma z, and x comma z is the element of R. So take note lang natin na dapat x is less than or equal to y, then bawal or i-remove natin yung x is equal to y, and yung y is equal to z. So balikan natin yung ating given, which is yung set x. Ito. So dito ang magiging x and y z values natin is 1, 2, 3 respectively. So kaya dito makikita natin x comma y, ginamit niya is 1 and 2. 1 and 2. Then dun sa y comma z, 2 and 3, bakit nila 2 and 3? Ito yung ginamit niya, 2 and 3, because ito nga x, y, and z yung ginamit niya. So para makuha si x at z, kuha lang yung x at z dito sa previous 2 na kinuha natin. So x dito is 1, kaya naging 1 dito. Z dito is 3, kaya naging 3 yung z dito. 1, 3. So next dito, tingnan ulit natin. Ang next is, ito yung ginawang x, y, and then ang z natin is yung 4. Kaya dito, x and y, 2, 1 and 2, then 2 and 4 yung y and z, kasi ito yung naging y, ito yung naging z. So para makuha yung x comma z dito, ito yung x, gagamitin yung x dito, so 1, gagamitin yung z dito, 4, 1, 4. Next, next dito is, ang ginawa is, ito yung naging x, ito yung naging y, yung 3, yung 4, yung naging z. That's why yung x comma y natin is 1 and 3. Yung y comma z is 3 and 4. Kasi 4 yung ginamit na z dito. So para makuha yung x comma z, ginamit lang yung values dito. X dito is 1, yung z dito is 4, kaya 4, 1, 4. Then yung last na possible natin na pwedeng makuha ng ordered pair is x, y, z. 3 and 4 yung x, y, and z. That's why dito yung x, y, 2 and 3. Yung y and z, 3 and 4. So yung x comma z natin, 2 and 4. And since itong x comma z, makikita natin dun sa ating relation, masasabi natin na transitive siya. So ayun, since ayun pumasok yung ating set or yung ating relation dun sa tatlong condition, kung reflexive ba siya, antisymmetric, and transitive, lahat naman yun pasok. So masasabi natin na yung x is equal to 1, 2, 3, and 4, yung relation niya is a partial order relation.
The other topic that we will be discussing is all about equivalence relation. Equivalence relation, it is defined as a relation R on set A is called equivalence relation if relation is reflexive, symmetric, and transitive. In other words, we can only define a relation equivalence when it is reflexive, symmetric, and transitive. In the previous topics, we discussed the reflexive as A is an element of set A where ordered pair A and A is an element of relation, and in symmetric we defined is as AB is an element of A where ordered pair AB is an element of relation, which implies that B and ordered pair B and A is an element of relation. While in transitive, it is defined as ABC is an element of set A where ordered pair AB is an element of relation, ordered pair B and C is an element of relation, which implies that ordered pair A and C is an element of relation. So this is our example number 1. We let A have the values of 1, 2, and 3, and the relation have ordered pair 1 and 1, 1 and 2, 1 and 3, 2 and 1, 2 and 2, 2 and 3, 3 and 1, 3 and 2, 3 and 3. So in order to know if it is equivalence, we need to satisfy if it is reflexive, symmetric, and transitive. So we need to find the ordered pair within the set A. So these are the ordered pair, and these are the ordered pair for symmetric, and these are the ordered pair for transitive. So now, if these ordered pair are present in the relation, then it is reflexive. If this ordered pair is also present in the relation, then it is symmetric. And last, if these ordered pairs are also in the relation, which is yes, it is on the relation, then we can say it is transitive. If we satisfy those three, then we can conclude that this is an equivalence relation. So for our second example, we let A have the values of 1, 2, and 3. Relation R have ordered pair A and B such that the sum of A and B is even. Relation R is a relation on set A. So before we can get the set of ordered pairs of relation R, we must find the Cartesian product of set A. The set of ordered pair of set A of Cartesian product A and A is 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. Relation R have ordered pairs 1 and 1, 1, 3, 2, 2, 3, 1, 3, 3, since we need to satisfy this, where the sum of A and B must be even. So once again, we need to find the reflexive, symmetric, transitive of set A. So after getting that, these are the set of ordered pairs for reflexive. If these ordered pairs are present in relation R, then we can say that this is a reflexive. If this ordered pair for symmetric is present in relation R, it will be asymmetric, but in this case, this ordered pair is not present in relation R. So we can say that this is not symmetric. So for transitive, we can also say that this is not a transitive. Why? Because this ordered pair is not present in relation R. So we can conclude that it is not equivalence relation since we did not satisfy the condition on equivalence relation where it must be reflexive, symmetric, and transitive. So that will be all. Thank you.